So let's use coordinate geometry to classify the figures. So it must be a triangle. And for the angles, remember, to classify the triangles, we have to talk about two things. One is the angle and one is the side. Would this be 90, less than 90, or greater than 90? Less than. If it's obvious, you don't have to do anything. It must be all what? Less than, right? So it must be acute. What type of size? I'm not sure. Maybe it could be all three equal, equilateral. It could be only two equal, isosceles, or it could be scalene, right? We can't really tell by just looking at it. So that we have to prove it, and it's a triangle. So for this one, we don't have to find the angles because we don't have to check whether it's 90 or not because it is not 90, it's acute. But sides, we have to use the distance formula, or you can just go ahead and draw a right triangle and use the Pythagorean theorem, which is same as the distance formula. So first side, I'll go ahead and use the Pythagorean theorem. Second side, I'll show you with the distance formula. And third side, what can we do for this third side? Just count it. 1, 2, 3, 4, 5. So I can say measure of segment EF was 5. You don't have to show work, but because it was vertical line, so you could just count it. So what about here? It is 1, 2, 3, 4, and 1, 2. So if you want to find this side, which is hypotenuse of this right triangle, you can use a Pythagorean theorem. So measure of side DF equals the square root of 4 squared plus 2 squared, right? A squared plus B squared equals C squared. To get rid of the squared here, you square root it, so I get square root of 16 plus 4 is 20. So it is about what? What's square root of 20? It must be 4 point something, right? So it is square root of 20. 4.472. 4.472. So those two are not equal. What about measure of side DE? And this one I'll show you with the distance formula. So here is what? 5, 7. Here I have 1, 4. So the distance formula was x2 minus x1. So 5 minus 1 squared plus 7 minus 4 squared. So I get square root of 4 squared is 16. 3 squared is 9. So square root of 25 equals to 5. So what can you say about this triangle? It has 2 equal sides this way. So what is it called? It is acute isosceles triangle. Okay, let's try the next one. So it's a triangle. This one, what do you think? This is obviously acute, right? Less than 90. This one looks like less than 90. What about this one? Looks like 90, or it looks like a little greater. Maybe not less than. I'm not really sure. So what do we have to do for this angle? You have to look at the slope. Okay? It could be 90. If it's not 90, I think it's greater than 90. Don't you think? Does it look less than 90? No. So it's either 90 or not. So what do? We have to look at the slope. If it's negative reciprocal, then it's perpendicular, right? So let's find the slope of GH. So slope of GH will be what? rise over run. 1, 2, 3, rise. Positive 3, up, going up. 1, 2, 3, 4. So it's 3 over 4. What about GJ? Slope of GJ. Let's see. So it is, we can stop here, right? It's halfway. So it's 1, 2, 3, 4, down 4, over 3, down 4, over 3. It's down 4, over 3. When you look at these two slopes, are they same? Can't be same, right? One is positive, one is negative. And if they intersect, it will be never parallel, so it will never be same. But are they flipped, top and bottom, and opposite sign? Yes, that means they are what? Perpendicular. So what kind of triangle is this? It's a right. What about the length? Can you have a right isosceles triangle? Yes, you can. You can have a 90, 45, 45. They are right isosceles triangle. But this one, since this is 90, these two cannot be 45s, right? So it looks like it is, right? Scale in, meaning what? They have all three different sides, triangle, but for sides, you have to prove it. So let's write the measurement of length, HG. Let me go ahead and use the Pythagorean theorem. So it's 3 and 4. Oh, that one, then you should already know it is what? 5. 3, 4 must be then this 5. Right? What about HJ? Let me go ahead and draw a triangle this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one we have to use the Pythagorean theorem. There's no 5:10 ratio. So measure of HJ will be square root of 5 squared plus 10 squared, which is square root of 125. What's square root of 125? 11.1. Let's do 3 decimals. 180. Right? What's the other side? Yes. Yeah. If we are doing third decimal, remember on the last progress check they asked for 3 decimals, so we're going to start practicing 3 decimals. And if it asks for 3 decimal, when it becomes 0, yes, you have to write 0. So measure of side GJ is, if you look at it this way, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oh, do you notice anything? 6, 8, then it must be 10. Why? 3 times 2, 4 times 2, then this must be 5 times 2. It's a ratio. 3, 4, 5 is a ratio. What's the other ratio that you can just remember and use it? 3, 4, 5, and 5, 12, then it must be 13. You can just memorize these and use this ratio. So this is what? 10. So were any of these 3 the same? No. So as we said, it is right scaling triangle. But you have to show word for the length.